Guys, can we start again?
Yes, sir.
Yes, doctor.
Okay, I want to show first of all what we are, where we are right now. We are still at the subject of what is we are still in this subject, Introduction to Artificial Neural Network. During this subject, you have learned about what is AI and the various types of AI, and you have also learned various types of methods. You have seen what is artificial neural network and the components of artificial neural network, and then you have seen the process of training neural network during the forward feed. The next part is we are going to learn about how we train the AI to become clever, which involves the back propagation exercise. Now, once we finish this topic, we have finished what university will teach you. Then we come to commercial issues and strategies. Here we come to, in actual work, what do you use AI for and how do you use AI for? So we are still in the first topic right now, okay? So, where is the AI capable of learning? It comes to where the AI need to do a lot of errors in order for it to adjust and learn. Okay, you saw just now in the forward propagation model, after learning, after trying to do something, finally the output will be compared with actual result or will be compared with expectations. And then there will be a calculation of error. Okay. Now, if you use the sigmoid function in your activation, you will see that where the error, we are actually trying to adjust the weightage in the connections. So there is, you can graph the weightage and the error in a graph like that. For example, when you have an error of 2, maybe you have to adjust the weightage by 1. When you have an error of 4, you have to adjust the weightage by 6. So you can see that it's not a linear function. 2, 1, 4 should be 2, right? But 4 is 6. So there is a curve involved. This is a hyperbolic curve. So hyperbolic curve, you remember just now the name of that particular activation function is a hyperbolic tangent, or the sigmoid curve, which is also a form of hyperbolic tangent as well, except that it stop at 1 and 0, where else hyperbolic tangent goes to -1 and 1. So we need to, in order to compute the rate of difference, because what we want to know at this point is what is the error and how much you need to change. This is important. You need to know how much to change. So you need to plot your error against your how much to change over here. So when you do that plotting, you are involving a curve, not involving a straight line. So this is where you need to use calculus in order to determine at that point in the curve, this is the rate of change that is happening. Okay. So the first of all, the basic premise is this. Basic premise is, what is your adjustment that you need to do? Okay. That error is taken from what is the output that you got or the output that you obtain minus the output that you expect, and then you square the result in order to remove a negative. Now, basically in implementation, normally people will also put a constant in front here to eliminate certain range of calculation deviations. Not deviation, calculation problems lah. You put some kind of a constant there. So this is called the gradient descent, because this is basically a gradient. You come here and this is a gradient. How steep is the curve is called a gradient. So you are trying to use the function in order to determine what is the rate of change at that particular point in where your error is. Because this, you are trying to get to the point where there is minimal error. Okay. So, why do you use a derivative? Why do you have to use calculus? Now, if your function is linear, it's very simple. Your formula is y equal to mx plus c. This will compute your rate of change throughout the whole curve, because the whole curve is a straight line. So throughout the whole curve, the whole function can apply. And then when you this derivative, but if you are using sigmoid where you are dealing with a curve, okay, the whole line of sigmoid, the S curve, is actually a curve. Okay, you look at the bottom of the screen here, we have a curve in the road. Okay, so we are like a human being. We carry a ruler. Okay, we carry a ruler, we go to the road, and we try to measure at that point of the curve in the road, what is the formula that we should use to derive the rate of, what is the rate of change that is happening at that particular point. Now, because we are human, we cannot get to a very precise number because we are too big for the curve. The point that we want to know is a very small point. It's a very, very small point. It's zero. Actually, there's no width, no height. So that is the point from where we want to, at that point, we want to calculate the rate of change. So compared to, let's say, for example, we are an N. An N will see that point in the curve like it's a very big thing. So it is able to compute that rate of change better than we can using a ruler. So we take the sigmoid curve and then we zoom up the sigmoid curve. So we see it in a bigger picture. Not we see in a smaller picture. We are going to macroscopic level. And when we go down to macroscopic level and we bring our ruler, we see that our ruler cannot fit the curve very well because it's a curve and our ruler is a straight line. But we can get some estimate. But as we zoom in further, we get a better estimate because we are going, using the microscope, going further and further and further in. We are trying to move towards zero in size. Of course, we cannot be zero in size, but we are moving closer and closer to zero in size. So that is called the limit. The limit is when you are moving closer to zero, but not exactly zero. So, Sir Isaac Newton and another German guy, I think Lieb, some kind of German name, they both came up with the formula of calculus. It's a technique, it's a workaround, how to compute something at the point of zero without really approaching zero, but almost to zero. Knowing that we cannot compute at the point of zero, but we can get as close as zero as possible to get what we want. So this is called approaching the limit. And that's why we use calculus using derivative for our back propagation later on. Now, again, the purpose of the back propagation is to compute the rate of change because we want to change the weightage and the bias that we are dealing with. So we are talking about rate of change. Just now, when we do the forward pass, we are not talking about rate of change. We are talking about getting the value of y from the value of x using that curve. Now we are trying to determine what is the rate of change in x. Not x, but what is the rate of change in x that we need to achieve. So we are using the rate of change now. Okay. Now again, I want to emphasize here, why are we using the sigmoid curve? Why are we using the curve to model whatever we are dealing with in AI? Why don't we use a straight line? Because the curve represent what normal life is all about. Normal life, for example, you will have your learning phase. When you are learning something new, initially you are learning at a very slow rate. After you have accumulated some degree of aptitude in whatever you are trying to learn, you are already learning at a faster rate. You have the basic already. But then you learn a lot already and you cannot learn too much anymore. So your growth is slowing down. So this is your rate of change. This is not your speed, but this is your acceleration. The rate of change in your speed. So rate of change initially is slow, your speed is slow, your acceleration is slow, then you accelerate very fast, then you come to a point of saturation where you cannot accelerate fast anymore, then you start to decelerate at slow pace. This bar chart represents your actual speed. The line chart represents your acceleration. So the acceleration is your S-curve over here. Speed is your green. And speed with direction, in the case of pendulum, is your blue because you're starting to go down already. So these are some other examples of where technology also goes through S-curve in terms of development of new technologies. Initially, it's very hard to develop new technology, and then suddenly there's everybody start to jump onto the bandwagon, and the technology accelerates very fast, and then the technology matures and then it start to age. So in order for you to survive, for example, in life itself, you must have multiple S-curve. After your first S-curve is declining, you start a new S-curve. And then when that declines, you start a new S-curve. So this is compared to the transistor question just now. So we are using a transistor technology. So transistor technology has already reached this stage where it is tapering off in terms of speed. We need to transform to a new form of technology in order to move higher. So we are going into quantum computing. There come a time when quantum computing will also decelerate, and then we need to find a new technology. So our overall growth will be something like the blue line. We keep on climbing higher and higher as a mankind. Because we put together a few S-curve. After this curve, we start a new curve. This is why in life we need to have continuous renewal, continuously learn new things, continuously develop new technologies, constantly find new ways of doing things. So it's coming back to S-curve, but it's an S-curve plus S-curve plus S-curve. So when you do backpropagation, depending on the type of activation function that you're using, you can see here there's quite a few activation function models that you can use. So this is the equation that you use in order to get the Y value from the input value. Y value is the output value from the X value if you use that curve. And then when you want to do the backpropagation, you want to compute the derivative, you use this formula on the right hand side. This is assuming that you use the standard formula. If you change the parameter in the formula, say for example you have 2 here, instead of 2 you put down here, it becomes 3, then you definitely have to recompute your derivative formula. Okay, this is what backpropagation is all about. Okay, if you don't understand, stop me and ask questions. Yeah. So you have already reached the output layer from the input layer just now. You have already reached the output layer, and then you already know how much is your error. Okay, error is the difference between your output and the expected output. Expected output can come from your own data. You already know that this is the actual data that happened, or you can try it in the real world, and then something wrong happened, and then you compute what kind of error that you get leading to that wrong thing happen. And then from here, what you do is you get the output size of the output, the error function, and you send back the error to everyone who gave you the error. Okay, what is this all about? Backpropagation is about distributing the responsibility to minimize the error rate. What you want to do is you want to minimize this error so that your prediction becomes more accurate. But who is responsible for coming out with this error? All the people before you. They were the one who produced the output, and when you take the output, you get the error. So you want to give back the error to them and tell them to go and adjust their process so that you get less error. Okay, but not everybody in this ecosystem, not everybody is responsible for producing the error at the same with the same weightage. Okay, some people are more responsible for the error, some people are less responsible for the error, depending on the weightage, depending on the output that they produce. So you want to distribute the error. Those people who are more responsible for the error must adjust more. Those people who are less responsible for the error must adjust less. So everybody must adjust accordingly. Only then you can reduce the error function. If everybody adjusts at the same rate, but everybody is not producing error at the same time, but they are all doing the same adjustment, then you get a different error, because some people will overshoot the solution and produce a new error. So you want to distribute the responsibility to minimize this error rate back to everybody who gave you the error in the first place, but according to how responsible they are in producing that error. And you must remember that we are operating in different layer. So you tell this guy, you produce that error. You make sure that you correct the error. But this guy said, I get this error from somebody else. So he also tried to send the error back to other people behind here. The same way, he also tried to send the error back according to who is more responsible to produce the error. I asked him to adjust more. Who is less responsible will adjust less. So this is the process. You give the error back to the layer behind you, and we'll take this particular, the last rectangle at the bottom of the hidden layer here. Okay, he has already received his portion of the error. Everybody now here receive each other portion. It's not the same now. You're not giving the same thing. So everybody has got something, and then you compute using that something, you get something else, where that something else is not the same for everybody. There's a formula for it. You will be able to learn that formula in a lot of textbooks. But basically this is what it's trying to do. You need to understand what it's trying to do first. Don't jump into the formula without understanding exactly what is this formula trying to do. What is the motive behind this formula? You need to understand the motive behind the formula, because in a real world situation, you need to adjust the formula so that your machine will learn better. So you cannot adjust the formula without understanding the motive of the formula first. What is the motive of the formula? That is what you are trying to achieve. That's your objective. So you adjust according so that you reach your objective. So this is trying to explain to you what is the motive of that formula. Is because you want to distribute the error to those people who produce you the error according to how responsible they are in producing the error. So you receive this error and you do some calculations, and then you adjust, first of all, you adjust your bias back again, because maybe your bias also contribute to the error. So everybody also does the same thing. So this particular guy, we're talking about this guy alone, he will adjust his bias, and he will also adjust his weightage. You see, the neuron behind him is producing some output that he received, but he doesn't use the output equally according all the input. He will assign a weightage, which input is more important to him, which input is less important to him. But he's the one who gave the weight initially. So now he must also adjust the weight, so that maybe he think that this fella is more important, but actually this fella is not more important, that fella is more important. So now he has to adjust the weight. And then at the same time, he also distribute the error. He received, let's say for example 10 for the error. He will distribute this error, maybe this fella 2, this fella 5, this fella 3, this fella something. So that now they will have to do the same process behind them and adjust the weightage and pass the error back to another layer behind them. So the whole process here is called back propagation. You understand this thing? So far?
Yes, sir.
Okay, I'm going to give you a simple example that is much more easier to understand, okay? You don't get this example on YouTube, or you don't get the example from website. This is, as far as I know, this is only here that you can get the example, and I hope with this example, you can explain to other people what an artificial neural network is confidently, because you understand it very well. Okay. You remember that you have your forward feed. That means the data is moving from left to right. And then you have your backward. You calculate derivation, then you do your back propagation. You reverse, and then you learn from the data. So this is talking about the forward feed first. Let's say, for example, okay, you are producing fish fillet. You guys know what a fish fillet is? Have you eaten fish and chips before? I'm sure all of you have eaten fish and chips before, right? The fish in the fish and chip is called a fish fillet. is a fish, but it's not looking like a fish anymore. It looks like a nugget. There is no bone and there's no head or tail or whatever. It's just pure fish flesh converted into a form of a nugget. This is called a fish fillet. So let's say your job is to produce a fish fillet. You run a fish fillet factory, okay? And then what are the raw material that you use to produce fish fillet? First of all, you need some spice. So you buy the spice from a spice factory. And you need some flour. You need some flour because you want to produce the nugget. So you also buy some flour from a flour factory. And of course, you also need a fish. So you buy fish from fishermen. Okay. You are one of the guys in the ecosystem, you produce fish fillet. But in the same layer, the manufacturing layer, processed food layer, you also have another factory that produce fish sauce. And you have another factory that produce fish paste. Your job is not to produce the fish and chip. Your job is only to produce the fish fillet. And then there's fish, another guy produce fish sauce, another guy produce fish paste. And then what happened to your fish? You will send this fish to restaurants. And then there's a restaurant that sells fish and chips. So this restaurant that sells fish and chips will take your fish fillet and use it in his fish and chips. Then there's a Chinese restaurant. The Chinese restaurant take your fish fillet and produce Sichuan fish using your fish fillet. And there's an Indian restaurant that buy your fish fillet and produce fish curry from your fish fillet. So these are your customers. Your customer buy your fish fillet from you. But they also buy the fish sauce from another factory. They also buy the fish paste from another factory. So they will put together the fish fillet, fish sauce, fish paste in a different process to produce fish and chip. This fellow will use a different process of the same ingredient to produce Sichuan fish. This fellow will use the same ingredient to produce fish curry. So, let's say the spice factory output to you, output is 10, okay? And flour factory output is 20. Fisherman output is 30. 30 fish, for example, or 30 kg or 30 whatever. Same thing with the other guys. So he send this output to you. And he also send the same output to the fish paste and fish sauce and fish paste factory. Okay? So the sample neural network, they will send the same output to everybody. Everybody connected to them. Now you receive the output, but you don't use 10. Maybe you use only 0.7 out of 10. This is your own calculation. You put the weightage over there. That's from your own calculation. And the flour, maybe you use 0.6. For fishermen, maybe you use half of that. This is your own weightage, okay? You put the weightage and then you produce your fish fillet using that. You also have a secret ingredient. You know, like Coca-Cola, you have a secret ingredient you don't want to tell people. No, you don't get it from anybody else. You do it yourself and it's a secret ingredient. So your secret ingredient is 5, for example. Over here, this is your bias. The same thing goes to the fish sauce factory. But he used different weightage because he wants to produce fish sauce, not fish fillet. The fish paste also receive the same ingredient, same output, but then they use a different weightage because they want to produce fish paste. Now, based on all this input that you receive, multiplied by the weightage, and you have your transformation. Maybe this is representing your sigmoid curve or whatever, some way of transforming the input. So based on the input that you receive, you get 50 over here. You notice that the weightage doesn't have to come to 1, you know, because this weightage is independent of that weightage. That weightage is independent, it got nothing to do with each other. So this doesn't come to 1. So it's just based on the taste or based on what you need to do. You take 0.7 of spices, 0.6 of flour, 0.5 of fish. So maybe here what it means is that flour is more important to you than fish because your formula is like that. Maybe somebody else, here is the spice is more important. And then flour is also more important, fish not so important. Maybe somebody else, fish is more important than the rest. So it depends on your formula for producing your fish fillet. And then somehow you do a transformation, you can produce 50 fish fillet. So this 50 is your output value, and you send your output value to the people who are expecting your output value. Let's say this is your output layer. So you're sending this to this fella, sending 50 to this fella. And what happened to this fella? He will take your output, but he will not accept all 50. Maybe he will take 0.9. Zichuan will take 0.6 because he has his own weightage. Fish curry will take 0.3 from you. They will compute the weightage and they will do whatever they need to do on their side. So whatever they have done, they also receive the fish sauce, whatever they also receive the fish paste. It'll go to the fish and chip, and fish and chip shop has a customer satisfaction of 40. Maybe it's 40%, for example, or 40 customer. Say they are satisfied with the fish and chip. And then the Zichuan fish shop say I got a satisfaction index of 60. Fish curry says I got a satisfaction index of 80. Okay, so here we see the forward feed process of the artificial neural network, which I try to give to you as an example of a food chain. Can you understand this? Any questions so far? Okay, right? So, maybe we can skip this break. Later we break for Isha. Once you receive the data at the other side, you find out that there is a deviation from what you expect. Let's say, for example, the fish and chips shop. They got 40 just now. They only expect 30, but they got 40. That means they got better than they expect. But maybe they don't want to have better. Maybe they want you to negotiate with them to sell cheaper. Now you have overshot their target. They don't need this kind of target anymore. Maybe because their shop is in a small area. So even if the customer is over satisfied, it's still the same customer. There's not many customer for him to get. So he say, don't give too high satisfaction, but give me a better price, because then I can have better profit. So he actually want to aim only for 30 customer satisfaction. He don't want to get 40. So there's a deviation of surplus 10 over there. Now the Zichuan fish shop got a 60 for his customer satisfaction. He expect only 30. So he has a surplus of 30 also. Wrong computation. He also has a surplus of 30. Now fish curry shop, he has a customer satisfaction of 80, but he expect to get 90. So he has a deficit of 10 here. So these are the error rates that you have, the error differences that you have in the output. Remember, these are differences, these are not score. The score is the one in the blue. The one in the blue is the actual score. The one in the orange is the expected score. This is the difference between the actual and expected. So we're talking about difference here. Back to the derivative we're talking about just now. So he's got deviation, and the fish fillet is informed about this deviation. The customer come and tell him. The customer come and tell him. Customer come and tell him. So he says, okay, who is responsible for this deviation? Okay, he is responsible. Some portion he is responsible. He got to adjust his weightage. But also some portion is not his responsibility. It's his supplier's responsibility. So he got to also tell his supplier to adjust their calculation so that he can overall send back a good calculation to the output layer. And the output layer will process all the calculation from all the rest of the manufacturer and try to reduce the gap between actual and expected. So back to the principle just now, the motive behind back propagation is to distribute the error according to responsibility. The one who have the most influence over the outcome must take more responsibility than the one who has the least influence over the outcome. So we come to what is back propagation. So here we have the error differences that we need to so these people will send back the error differences to this guy. This fellow will send back to this guy. This fellow will send back to this guy. But he doesn't send the whole thing. He will allocate the error according to our responsibility. Let's say, for example, the responsibility for this error in the fish and chip is not only coming from the fish fillet. It's also coming from the fish sauce. It's also coming from the fish paste. So he has an error of 10, that he need to dilute. So he give back 5 to this guy. Maybe he give back something to this guy, 3. Maybe he give back 2 to this guy, for example. So he distribute it according to the influence that this person had on his total error. And the same thing with this Chuan fish. He also send back the error to this guy. And fish curry also send back his error to this guy. So what you do as a fish fillet, you do a backward of your forward feed just now. You re-aggregate back this error and compute something else. And then once you compute something else, there's a way of calculating it. It's not necessary you just add the figure. So it may be 27 minus 5. This is just simple adding. Or maybe you go through some formula to get the error. Now with this error now, you distribute this error. Okay, first of all, you compute the aggregate. The third one is you adjust your own bias, your own secret recipe, not involving everybody else. There's some formula there, you adjust your bias first. And then you also adjust the weightage that you assign to your input. So here we are not talking about replacing the weightage. We are talking about adjusting the weightage. So last time maybe your weightage was 10. So if you add 0.2, it becomes 10.2. Or maybe your weightage was 1, now it becomes 1.2. So you're talking about the difference in the weightage that you want to get. So the other network connection, you adjust it by 0.1. You increase by another 0.1. Maybe another weightage you adjust by reducing 0.1. So what you are doing now is you are changing your bias and you are also changing your weightage. Okay, from the error. From the error you adjust based on the formula. With the formula is basically you taking the total weightage and then you multiply by your own contribution to the error, and then you also multiply by the weight of the weightage. There's the formula involved there. And then you also have your error that you send back to the people behind you. Why you send back to the people behind you? Because then you ask them to go and adjust their own process behind them. So everybody got to help you in order for you to reduce your contribution to the total error. This is the process of back propagation. The intent behind it, the motive behind it is very important for you to understand, so that you know which formula to use, or you can tweak the formula according to how you need to train your model. Get me? Okay.
Yes, sir.
Yes, sir.
Yeah, okay.
Sir, I hope that the hidden layer,
Yes, sir.
fish sauce and the fish paste are also hidden layers.
Yes, this is a hidden layer. Correct.
Okay. Now things are clear, sir.
Yeah, I think this example will make it very clear to you. I think now you can go back to your dormitory or to your flats or to your houses or whatever, and you can explain this to your friends. You know, what is artificial neural network? Using this example, I think everybody can understand artificial neural network. Right?
Yes, sir.
Okay. So now you understand the process of forward feed and back propagation. This is very important to you in order for you to be able to train your neural network in the future. It applies to all kind of architecture and all kinds of situation. Now, the other variable that you have to think about is your architecture of your artificial neural network. You can see here there are a lot of patterns. A lot of patterns here. Some are circular, some have, you know, so you can see some have no layers. In fact, some have different funny sort of layers. So you have to choose the right architecture in order to train the data that you want to teach. So maybe this architecture is not right, that architecture is right. So you can see, for example, there's an architecture here that uses a technique called compression. Compression is where you're dealing with a lot of data, and then you actually compress the artificial neural network so that it becomes smaller in the middle, and then it become bigger again. This one is involved where you try to classify things into categories because you don't want to make too many calculations. So if yours is not small in the middle, for example, you'll be doing a lot of calculation across from left to right. But when you make it smaller, you're reducing your calculation. And then you extrapolate the calculation back into a real world solution, you expand it back again. But the number of calculation that you do is small. You see, because the whole process of artificial neural network, get this correct, is that you want to achieve certain objective, but it's not only that you want to achieve the objective. You want to achieve the objective economically. Okay? Because if you cannot achieve your objective economically, maybe you will not have enough resources to solve your problem. So no point. You trying to become perfect, but you cannot solve your problem because you don't have the resources to do it. Or you have the resources, but it's too expensive. So people who need your solution is not willing to pay that much for that solution. Okay, so let's say for example you sell that cosmetic solution to cosmetic shop. So cosmetic shop, maybe they don't want to pay so much, they want to pay so little. But then for you to train using your model, you need to have too many computers, you need to consume too much electricity, you need to spend too much time, and they are not willing to wait for the time, or they're not willing to pay for the cost. So they're only willing to buy at the cheap cost. So you need to also be efficient, not only be produce the result, but produce it efficiently. So you have to determine your objective properly. Okay, this is my objective. I don't want to feel hungry. So how do you don't want to feel hungry? You can eat bread or you can eat a steak. But if your objective is I want to not to feel hungry, but I want to be very satisfied in not being hungry, then it's a different game altogether. So all that need to be considered when you are designing your artificial neural network. Okay. So you have to think about your end architecture, and you can see here that all the example that I've given you just now got only one hidden layer, but in the real world there are multiple hidden layers involved. Okay, it can range from 10 to hundreds or to thousands of hidden layer is already very expensive to process. It's not likely to move beyond thousands, but there are some people who are willing to pay, and for important reason they want to do that. Then they may have a better learning model, a model that can learn better. So the point here that I want to say is that this thing that you see on the right, this thing called artificial neural network is a model. Okay, that model has many variation in the model. And the model itself, apart from variation, you also have many parameters, and inside the model itself, you can also adjust many parameters. The parameters can be methods, can be weightage, can be figures, can be something quantitative, but it also can be, the whole architecture also can be different. Okay, so this model has proven itself that if we use this model, we can teach machines to learn. So this is why we are using a lot of artificial neural network, because the model works in terms of providing a capability for machines to learn. Okay? So any questions so far? Now we look at the machine compared to a real human brain. The artificial neural network is a very simplified version of the human brain. Like I mentioned just now, the human brain does not use purely binary signals. It's using analog signals. So it's a richer variable that is using, because instead of 0 and 1, it can range to anything. And then the human brain also has, you see, what we call a neuron in neural network. Neuron is actually the connection between human brains, the dendrites and all that. So you can see that the human brain is involved with a lot more parts. You have the nucleus, you have the dendrite, and you have the axon here, and the terminals over there, the dendrites over here. So human brain has more mechanism in the neural network itself. Whereas our neural network is very simple. You have the neuron, you have the connection, you have the weightage, you have the bias. Very simple compared to the human brain. So that's why the human brain is able to learn faster, able to handle a greater diversity, and able to handle a lot of problem situations using one brain. You try to produce one artificial neural network that can learn about everything, about how to drive a car, about how to stay healthy, about how to have a good relationship with your friend. You cannot have one neural network, because that one neural network is only specific to learn about something. But a human brain can learn about a lot of things. And how can it achieve that? Is because of the nature of the human brain as compared to the neural network. Don't believe that the neural network mimics the human brain. It's not the same. But regardless of the fact that it's not the same, what we have right now, today, the neural network is a good model for us to be able to teach machines. Now, if you want to move forward from here, maybe what you can think of is think of a different model that is not a neural network, that is something else. Like before, there's no neural network, then somebody think about neural network, and then he got a model that is able to be trained. Maybe you can also think of something else that can be trained better than a neural network. Then you solve the problem of resources or whatever. So that's moving forward basically. Alright? Well, okay, now we can take a break. After this, what you have learned just now are all the things that you learn normally in a university. But here we are going later into what we are going to do in the industry. We are going to use a recurrent neural net into deep dive into, okay, this is what you learn in university, but in the real world, this is what you actually do. So that you have an appreciation of once you have finished studying, you need to apply this, how you need to apply this in a real world context. Okay, so we take a break now. Maybe we have Ishak prayer. Is that okay with you guys? Doctor? Oh, you want to ask questions first right now? Maybe you can spend some time just asking.
No problem, sir.
Sir, I have a question.
Yes, yes.
I'm a bit confused about when we try to do backpropagation is we want to fix any error in the prediction, right?
Yes, that's right.
So what is the difference between we use backpropagation to fix the error and we train back our model? When are we going to use like the method? Is there any method that we train again our model because it doesn't do what we want it to do? And what is the difference between using backpropagation and using other methods? Or is there any other method?
Well, in the first place, there is no other method lah. There's only backpropagation. But why do you do backpropagation? To answer your question, another way is you erase everything. You put another random. Normally, what you do in a neural network is when you start, you have nothing in the weightage. Okay, so you put some random number in the weightage, and then you have your input value coming from the environment. So the input value coming from the environment is going to work against the random weightage, and then you compute the error. Then you go back and adjust. Why do you go back and adjust? Because then you have a direction. No? You know how much error you have, and then you have a method of how to distribute the responsibility to do adjustment back to the people inside you, and then that's called the process of backpropagation lah. But if you don't want to do backpropagation and there's no other way, so what you do is you erase your model, then you start with another set of random weightage. So this is just like trying to gamble lah, kata your 4-digit number or something. So because you don't have any basis though, you are just starting with random number, starting back with random number, there's no direction involved. But here when you use backpropagation, you have direction. You start with random number, but then you know what is your error. And then based on this error, you adjust back again throughout your line. You distribute the responsibility to do the adjustment back to your line. So there is a direction there because it's directed by the error that you're getting. So this is the reason why you do backpropagation. Alright?
Okay. Thank you, sir.
Yes.
One more question.
Yes.
Like, just now you use TensorFlow sandbox, right?
Yes, TensorFlow playground. Yes, that's right.
In that example where we can't get the desired output.
Correct.
So we change the activation function. So is that some of the method also? Because
Yes. Just now was only some of the method. I recap what we did just now. We changed the activation function. Correct. We changed from hyperbolic tangent, then we changed that to linear. Remember? But we also add another layer. Remember or not? We add another layer to the hidden layer. We add, it becomes 3 layers.
oh yeah.
And then we also increase the input parameter. We increase this to the checkboard kind of input parameter.
Yeah.
So we did a few changes kat situ tau. It's not just only the activation function. So and this sandbox is just a sample. This is not the real world. Does not work this way. The real world, you change a lot of things. You do a lot of experimentation, you change a lot of things. Okay, but you can see from here, you can feel, once we did all these changes, and then especially once we change it to, number one, we increase the input parameter, and we change the additional layer, and then we change the hyperbolic tangent to the linear activation function. Suddenly, your rate of learning is so fast. Whereas when you start originally, it refused to learn. So in the real world, you will come to a point where your model refuse to learn. Okay, your model don't want to learn anymore. So that is a problem because you cannot overcome that problem. It doesn't want to learn. Number two is it can learn, but it is learning very slow. Too many steps. Remember just now when we did that, there was too many steps. So we also need it to learn fast. Kalau we don't want it to learn in too many steps because it is too costly for us. So we want it to learn fast in terms of time. We can come up with the solution faster than other people. Then in terms of cost also, we don't incur too much computing cost, resources and whatever. So those are the two things that's important for you. Number one is to be able to actually come up with a solution. You cannot come up with a solution at all, no point. You cannot even solve your problem. But even if you can come with a solution, you must be able to do it in an efficient way. So how to be efficient? You have to tweak all these things. It doesn't mean that, okay, you go out there, you do something, oh, you already achieve your target. No, but then can you achieve your target faster, cheaper? That's also very important in the commercial world. Alright?
Okay, thank you, sir.
Yeah, most welcome. Any other questions?
Hello, sir.
Yes, yes.
Can you go back to the fish fillet?
Okay.
For the back propagation,
Propagation
part. Okay. For one iteration, I want to understand whether is it just it going forward or like the updating every time it updates.
Then you go forward again. Second round.
Oh, then you go forward again. Then it's considered second iteration.
Yes, second iteration. So when we did the tensor flow just now, remember we have this number at the top, this playground. Remember we have this number, the epoch. Remember we had the number coming up to 100 plus, then going down to 50 plus, then going down less than 10. Remember or not? We had that. That is iteration lah. That's number iteration that is doing.
Okay. Thank you, sir.
So this example just now, the one that we saw regarding the game, this one, he did something like 50,000 iteration, this game, in order for it to learn, to train the neural network. So the one that we saw just now, initially, okay, the game was not very good. This is after he's already clever. So initially it's like this. You can see that neural network is not well formed yet. You don't see a lot of lines. So the connection is not there yet. So this fella is running very slowly. And then he's doing all the wrong things. He's just trying to do this, trying to do that, not knowing exactly what. So the machine is actually pressing the key. The machine is pressing the key on the keyboard to ask the fella to move forward, jump, go down. You see now he got stuck over there. He got stuck because he's pressing the wrong combination of keys or whatever. So this is one iteration. Then he goes back and do another iteration. Goes back and do another iteration. This generation is 0. So if you move up to a few generation ahead, he's already very clever. This is generation 25, species number 10, genome number 7. So he's gone through so many iteration and so many different pathway of testing. So when you do experiment, you actually have this. You have generation number what, of species number what, of genome number what. Because then you want to take your neural network and then you want to save a copy. So you classify your copy because maybe you have, let's say for you start with 1 and then you do some changes and then but you don't want to overwrite number 1. So you do some changes and then you proceed. And then but then you still maintain the old copy, then you change in a different way. And then this is species number 2. Species number 2 got some difference, some change here but not change here. Maybe species number 1 use hyperbolic. Species number 2 use linear. Species number 3 use rectilinear, for example. So you have all those lah. So eventually when you have done enough iteration and you have done enough experiment, you get lah something like this also. Now he's very clever already. You can see the neural network, they already understand about a lot of things. So he knows when I see an object on the screen which is on the left and an object on the screen, I must press key A or key, the one on the right is the key on the keyboard. Up, down key, X key, A, B key. So the meaning of the key is do this, do that lah. So he can see, oh, if I see this thing, press that key. If I see something like that, press this key. So you can see the connection is already being done over there. So there's a neural network behind that does all this figuring out the thinking behind that.
Mr. Galizan, I
Yes?
have a question.
Sure.
What's the difference between epoch, batch size, and iteration?
Okay, coming back to that. These are just terminology that this is not a standard terminology. This is only a terminology that is used in the apa ni? In the where is that? Wait. Okay, you see here there's epoch right here. So epoch here actually is the iteration. How many iteration has it done? But here on this playground they call it epoch. Maybe somebody call it iteration. Another person may call it generation. For example, like in the game they call it generation. The game is generation, and then they also have species and whatever. So it's up. This is nothing to be worried about. These are not your standard terminology. These are just what people want to call it basically. But I want you to understand the importance of that thing called generation is iteration. I think that's very easy for you to understand. Here we have something called species. Remember just now when we saw it, there's something called species over here. So when you are actually running your model later on, maybe you're going to change some of the things though, but you're not going to change something else. So that's where you create different species, and then you still keep your model. You still that whatever you generate, you store inside database or whatever, that your values, your weightage and everything, you record and you keep somewhere else, a text file or database or whatever. You see, this is generation number 24, but this is species number 31, genome number 13. So maybe species is a subcategory of genome. So genome is only 13. So basically he may have a way of classifying his testing. He's actually running a lot of tests. It's not just one single test. Maybe one test is to use different input parameter. Another test is to use say different activation function. Let's say for example genome represent activation function. So he's testing 13 different activation function, one for each genome. And then under each species he's testing different input parameter. So this species means using this input parameter, but this species means different input parameter. Okay. So you when you are running your test, you need to maintain a few copies of your test. But these are different type, because you don't know which one is most efficient. So you run actually a lot of tests in slightly different tests against this one, So when you are running the test, then you are actually doing the iteration. So one iteration is not enough. The same model will go through maybe 1,000 iteration. So another model go through another 1,000 iteration. So the model is your genome and your species. Okay. So maybe this fella is dividing it into genome and the category is genome, the subcategory is species. So you got 2 level, genome, species. Maybe for you it's not enough. Maybe you need to have 3 level, 4 level, 5 level. So you can use whatever name you want. You can use it species or genome or kingdom or whatever. But still the idea is that you need to do a lot of experimentation to see which one works for your particular situation that you are trying to produce a solution to. Get me what I'm trying to say? A lot of experiment. Yes.
Sir,
Yes.
about the TensorFlow slide, actually when sir change the activation function, change the input, what I see is the objective we must make sure we minimize the loss function.
Correct,
Is
correct.
it true?
Yes, yes, yes.
So in the real world, in the real experiment, when we try to get the better algorithm or better model, so the objective, the aim is we must also make sure the loss function is minimized.
Yes, yes.
In the
Correct, correct, correct. You need to minimize the loss function.
Loss function.
Yes, this is a basic parameter that you are trying to monitor.
So when we adjust the activation function, adjust the hidden layer, or so the aim for make sure our algo or model is better, make sure the loss function is minimized.
Yes, that's right.
Is it true?
Minimize in an economical way.
Okay. So it's achieve lah our objective efficient. Our objective is economically. So that is the reason why our we must make sure the minimize the loss function.
That's right, that's right, that's right. Okay.
Okay, thank you, sir.
Now that is talking about objective. Your technical objective. Your technical objective is to minimize your loss function. That's technical objective. But what is your business objective? Okay, the business objective, now you have minimized your loss function and then your AI works properly for that particular purpose that you are designing it. So, but is that the right business objective? Let's say for example, your strategy is to sell burger. Okay, what is your objective? Your objective is to sell the most burger, or your objective is to sell most profitable burger. So most burger may not be most profitable. Maybe you can sell your burger the most if your burger is super duper tasty. Okay, so but then your cost is also so expensive. Okay, maybe your price is the same. Price is the same. This burger is also 15 ringgit. Another guy, your competitor, also selling 15 ringgit because the price is the same. You cannot fight each other. So you are trying to fight against quality. So you are trying to sell the most burger, by making it taste better. But every burger you only profit 50 cents. Okay, this guy is different. This guy is not selling the most burger. His objective is to sell the most profitable burger. So the most profitable burger, maybe he can add a lot of things inside the burger. The price is 15, but then his potato chip is more than yours. Yeah, maybe he also has a lot more vegetable, and then he put in mashed potato, put in all kind of nonsense, and including free drinks as well inside the burger. So but his quality is very poor because he's putting a lot of things. So his quality is very poor. So maybe the quality is very poor, but his profitability is more. His profitability is 1 ringgit per burger compared to you only 50 cents per burger. So that is the business objective. So then you take the business objective and then you translate it into your technical objective. What are you trying to achieve here? Okay. So in order to do that translation, you need to do a lot of thinking lah, in terms of from the business point of view. Before you do the technical part, you do the business part properly first. If you are dealing with other people, you are dealing with the business owner, or you're dealing with your superiors or whatever, make sure they get their business objective correct first. That can be translated into your technical objective. Because if your business objective is not correct, these people don't really understand or don't really have the clarity of what business objective they should frame for. You are going to end up chasing after the wrong technical objective, which is resource hungry, which is going to take a lot of effort, doing the wrong things correctly. Doing the wrong things correctly is very expensive. You might as well do the right things incorrectly, but you are doing the right things. For example, katakan, what is doing the wrong things correctly? Let's say you know how to navigate a ship. You know how to drive a ship, okay? A ship, oil tanker, for example. So you can drive a ship correctly. How to drive an oil tanker? There must be some way of how to drive an oil tanker, how to sail an oil tanker. So, but you know how to sail correctly, but you got the wrong objective. So the first objective is to go to Saudi Arabia, but you are going to Japan. So you are sailing the ship correctly, but you are heading towards Japan. Suddenly in the middle, you get an instruction to say, sorry, we are not going to Japan. We go to Saudi Arabia. So your ship got to turn around and sail back to Saudi Arabia. This is very expensive. Compared to, for example, you know from the start, you are going to Saudi Arabia. But you don't drive the ship correctly. You drive maybe 80% correctly or 50% correctly. So instead of going at 10 km per hour, the ship is going at 5 km per hour. But it's already in the right direction. It's more important that you are in the right direction even though you are not doing the things 100% correctly, rather than for you to go in the wrong direction but you are do it perfectly. So you have to do the right thing. Whether or not you do it correctly, better than for you to do the wrong thing but doing it correctly. So it's back to when you mentioned about objective tadi, you have to think about what is your technical objective. When you're asking a question from a technical objective point of view, yes, it is to reduce the cost function. But from the overall perspective, there is a higher objective than that objective. That higher objective is your business objective. That objective must be framed correctly and translated into a technical objective in order for the whole thing to be done within the time frame, correctly, get the result that is intended, and blah 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 blah. Okay? Any other questions? Hello? Hello?
No, sir. No, sir.
Okay. So we can take a break. When can we, let's say we do Isha prayers first or something like that. When do you want to? The next one that we are going to do after this break is we are going to now go into real implementation. What you learned just now is just whatever you learned in university. It's a summary of what you are going to learn. So now we are going forward into commercial issues and strategies. We are going to learn that by deep diving into recurrent neural network. So, Dr. Izam, when can we reconvene?
Mr. Khalizan, I think maybe we could just have a 5-minute break and try to finish our lecture today around 9:30 or something. Can we manage that? Do you think?
We can set a time limit, but I don't think we can finish the lecture. Or maybe we stop here first and then we continue on another day with because it's still quite a big topic. The recurrent network is quite a big topic.
Okay, I see.
This is like how to apply it. This is neural network, what you saw just now. But in the real world, your neuron is not just using one graph. Just now, your neuron, the activation function is using one graph, which does not use a lot of thinking. Basically, you look at the X value, you look at the graph, then you get the Y value from the graph. But actually, in here, when you want to fire that thing, you're actually going through a process. Your neuron is going through different state changes. State number 1, state number 2, state number 3, state number 4, before that neuron decide to fire and what to fire. So this is the real world application. It has involved quite a bit of explanation, basically.
Okay. So maybe we have 5 minutes break and we can continue after that.
Okay, alright.
Okay, so that we can make it faster, quicker.
Okay.
Alright. Okay, 5 minutes break.
Okay, guys, can we continue?
Before we start, can I ask a question? Can deep learning be combined with reinforcement learning?
Reinforcement learning is a type of deep learning. Deep learning means there are multiple hidden layers. A lot of hidden layers, deeper deep learning. Reinforcement learning actually use multiple hidden layers. So, reinforcement learning is actually a type of deep learning. So, Any other questions? Any other questions as I backtrack through my slides?
No questions.
Hold on, I'm trying to backtrack to my slides. Going back to the previous slides. So in the real world, how is AI in the real world different from AI that you learn in universities? Okay. These are a few development issues that you face in the real world. The first issue is that the machine is not learning. Just now you saw in our TensorFlow playground example, sometimes the machine does not want to learn. Or it is learning but it is too slow in learning. It's using too much resources, too expensive, or impossible for us to go ahead because we don't have the resources to complete the learning. And the next question is, should we use analytics or should we use AI? What's the difference between analytics and AI? Okay, analytics is when you know the rules. You know the rules and you need to just classify your data according to the rules. AI is where you don't know the rules. So you use AI in order to develop the rules. And finally, another problem that we have is normally the data quality. This is very normal. Data quality and data quantity is not enough for us to train our machine. So what do we do in that situation? So we need to solve these development issues in the industry itself. Okay. So in order to do that, we are going to deep dive into a type of deep learning called recurrent neural networks. Okay. Now, in a normal, just now what you saw was a normal artificial neural network. This is where you have an X value and then you produce a Y value. Now, in a recurrent neural network, what you do is you put in an X value and then this X value also become the input for another round of calculation. And then finally, only after a few rounds, you produce the Y value. Okay, if we expand this last chart, if we expand the loop into an expansion, this is actually what we do. Within each neuron, what we do is the neuron is undergoing several states, okay? And what you do is you compute the state and then you store the state somewhere. Because later on you're going to need the state again when you do back propagation. So this is one neuron. What you do is in one neuron is, first of all, you put in the input value into the first state. It is the same neuron, but it's the first state of neuron. And then you get the output of this first state, you pump it into the second state. And at the same time, you pump in the input again into the second state. Okay? And then this is pumped into the third state, and finally you pump into several states until you finally get some kind of Y value. Okay, it goes through several steps. Now, why does it go through several steps? Later I'll show you. This is something similar to blockchain. Blockchain is where you have a data and then you compute the hash data for that data, and then you use the hash data, you input it back into your second page of data. So you have the hash data, you add more data inside here, and you compute a new hash. And then this hash is chained into here, that's why it's called a blockchain. So the block is the block of data, and every block has a signature over there that is carried forward. So the purpose of this is so that you cannot manipulate any of the data anymore, because if you manipulate, then the hash will change. And the hash will change, that means all the hash will change. And then when you compare the hash does not agree. And then you distribute this over so many different servers, it becomes almost impossible for you to adjust your data that you have input earlier on. And this provides you with the integrity of the data in a blockchain. Now, in a recurrent neural network is the same, but the purpose is not to maintain data integrity. The purpose is, later I'll tell you the purpose, but it's more or less the same as what you compute over here. The result of computation goes into the second calculation, which still take the same input, but then also take the calculation from the previous state into account, and continue. So this is like a calculation across time or across sequence of events that happens. So what is recurrent neural network is good for is for learning from sequence. Sometimes the sequence of data is important. Sometimes only the quantity of data is important. Quantity of data important, for example, if you want to sell burger, how much burger do you sell? It doesn't matter whether you sell the burger yesterday or today or tomorrow or last month or last week. It's only how much burger you sell. That's important. But sometimes the data is a nature such that sequence of data is important, not only the quantity. Because there is meaning in some sequence. For example, if you say, I eat to live. So there's a sequence there. I eat to live. Number 1 is I, number 2 is eat, number 3 is to, number 4 is live. And then you say differently. You say, I live to eat. Okay? So what's the difference here? So there's a difference meaning. Difference in meaning is I live to eat means he enjoy eating. So his purpose of, so this person who doesn't enjoy eating. He only eat because he need to live. So in order to live, he need to eat. So he doesn't care what he eat. I eat to live. But another person might say, I live to eat. So the purpose of his life is to enjoy eating. So it's two different meaning out of the same words but in different sequence. Okay. You look at, for example, an example of machine learning, which is Google Translate. Okay. You look at the word here. The ASEAN community is comprised of 3 pillars, namely the ASEAN Political Security Community, APSC, ASEAN Economic Community, AEC, ASEAN Social Cultural Community, ASCC. The ASEAN Health Cooperation is under the ASCC pillar. Okay. When we translate it into Malay, you see, first of all, the wording has changed in sequence. ASEAN Community is not translated into ASEAN Community, but it's translated to Community ASEAN. Already reversal. Terdiri daripada 3 tonggak, iaitu Community Keselamatan Politik ASEAN. So just now was ASEAN Political Security Community. But when it's translated, it changes sequence into Community Keselamatan Politik ASEAN. So the first word here is ASEAN, but the last word here is ASEAN. The sequence has changed. So this is called the coder-decoder model, where the coder understand what is the meaning inside the English word, and then try to derive what is the intention of this meaning. Okay. So once it has the intention, only it decode it back again into Malay. So this is called the coder-decoder model, where there is an intent in the middle. So the coder tries to get the intent, and the intent is then decoded back into here. So this is going to be, this is mostly applied, for example, in situation where people do sentiment analysis on social media, for example. Somebody may say something, but he means it sarcastically. You know the wording that he used. For example, you may say, "Oh, you are clever." That means you are trying to say that person is clever. Or you are trying to be sarcastic to that person. You say, "Oh, you are clever. That's why you are so stupid." You know, so same word can carry different meaning. So the sequence of words that you use and the context that you use and all that has important implication in terms of sentiment analysis. So this is being used in AI for sentiment analysis. So other applications is text generation, for example, generation of music, because musical note sequence is very important. Medical regimes, you know, when you try to treat people for tuberculosis or something very complex, let's say for example how to recover from COVID fully. So the sequence of what you do, the action that you take in providing medical or healthcare to the patient, including the sequence of maybe a recipe of antibiotics that you give to the person or something like that, has an important implication in terms of the meaning in that sequence. Sentiment analysis, now I give you an example. So what we are going through later is an example in the stock market. Okay. So again, recurrent neural network is used in order to learn from sequence. So here's example, okay. So where we use, we can use recurrent learning, artificial intelligence within the context of trading. Whether you are trading stock, you are trading commodities, or you are trading forex, you are trading derivatives. So when I was 24 years old, I started a stockbroking firm. When I was 27 years old, the stockbroking firm became one of the top 10 in Malaysia. So this is me trading. So you are going to see this is how you do a trade. So this is forex option, okay. Forex option is one of the derivatives that's involved in this kind of trade lah. So you basically have a lot of graph, and inside the graph there is meaning. You can see there's a lot of indicators here on the screen. These are the indicators that I use. Okay, the first indicator is called the Rsi Indicator, to see whether the here is forex, whether the forex is oversold or undersold or something like that, and then overbought or undersold. And then the bottom indicator is the momentum indicator. So maybe the price is rising, but there's no momentum there. So you need to also watch at the momentum of the direction that is going. You can say the car is going in left, or the car is going right, or the price going up, or the price is going down. But is there a momentum in that price or not? By going up or going down, how much momentum is there? So I'm looking at these indicators, and I'm looking at the pattern in the chart. You see the red line in the chart, those are moving averages. So sometimes the actual price, which is the white color, is moving too far away from the moving average. Sometimes it goes back to the moving average. Sometimes it crosses the moving average in the other direction. So all those are, to me, that is something that indicates something. And then I decide whether I want to buy or I want to sell the stock. Because I can make a profit when I buy, and I can also make a profit when I sell. So it depends on the direction of the stock. For example, if I expect the stock to be to increase in price, what I do is buy. Because I buy, then the stock will increase in price, then I sell when the price is high. But if I expect the stock to reduce in price, what I do is I sell first. Then I buy back the stock. When I get a green indicator like that, that means I'm making a profit. So this one, I'm making a profit on a selling position. Red just now. So now I'm looking again at the chart. You can see in a few minutes, in maybe 5 minutes, I'm making profit from selling and from buying. Because I'm reading the signal from the market, using all these indicators and using the graph of the price itself. So I just bought one now, that's green means buy. Now I'm thinking that now the stock is going up again. So if you look at the graph now, it's very hard to guess whether it can really go up or it's really going down. But I am betting that the stock will go up. So you can see now the stock is going up because I've read some indicators from behind. I think the stock is going up. So we will see now whether the stock is going up or going down. It's already gone up, whether it will fall before it reaches the red line. The red line is my finishing line. So if I hit the red line when the stock is up, then I make a profit. But if I hit the red line while the stock is going down, then so I'm still making a profit, a green figure. But it has already started to go down. So I'm checking, these are all the trades that I'm checking a few other graphs. Which graph is beautiful? So I only trade when the graph is beautiful. I don't trade when the graph is not beautiful. For example, when the market is moving sideways, normally I don't trade because it's very hard to read the signals when the market is moving sideways. Okay. Now I'm selling. I don't buy. Now I sell first. I sell first, then later I buy back. So I'm thinking now that the price is going down, and the price is really going down right now. So So you can see sometimes stock trading can be quite a nerve-wracking exercise because it can move in either direction. But here we are moving towards the red line. Again, I'm making a profit over here because I now when I hit the red line, I buy back whatever I sell. So because I sell higher and I buy lower, so I'm still making a profit. Okay, so it moves in that direction. You can see that I make profit when I buy and I also make profit when I sell because I'm reading the signal. Now, how do you apply this to the industry? You can see here, this is what I can do is, even though I know how to trade, but I can only do for myself. I can only do for one person because I don't have the enough brain to handle like 20 customers at the same time. Because I'm doing the trading very actively. I'm looking at the screen and I'm doing the trading very actively. I cannot handle 20 screens, for example. I won't remember what is the strategy over here, what strategy over there. But when you use artificial intelligence, and now a lot of stock trading, forex and all that is working against artificial intelligence. In fact, the one that I'm fighting against just now was also probably a lot of artificial intelligence. In the Japan, for example, 60% of trade is done by artificial intelligence. In US, 40% of trade is being done by artificial intelligence. In ASEAN countries, it's a bit lower. You can see this guy is taking care, each of these guys is a trader just like me. But they are all taking care of many customers. They are not taking care of one customer. The real brain behind this are the programmers who write this program. So this is one area where after you graduate, you can go and look for a job to program the AI for stock. Because the AI for stock never stop. Because you are fighting against another trader. Another trader is fighting against another trader. Everybody is fighting. Everybody is improving their AI. Everybody is improving their AI and everybody is fighting the AI against AI. It's a AI versus AI battle all the time. So there's always a need for programmers. So you can see how they're trading now, how fast they are trading compared to what I trade. I'm not trading as fast because I'm doing it manually, but they're doing it very fast over here. Okay, it's back to a lot of mathematics involved. So this guy is explaining that there's not many traders around. The real people are the programmers behind it, not the traders. This is the chief programmer. So he's saying.
Sorry, I have a question.
Yes.
I want to know, is the equity market is all use AI to fight?
Sorry, again your question.
I want to know the equity market, the stock is use AI to fight.
Yes.
And how to decide which AI is the winner in this market?
Okay. Let me just show you a bit more here. I just want to show. Okay, let's look at what is. I'll answer your question shortly. Let's look at what these people are doing. These people are the traders. Okay, they are just looking at the trade being executed, but the trade is being done automatically by the machine. Okay, but there is a bit of human supervision on top of that, just in case something goes wrong. For example, when there was a panic Monday, for example, when it happened, the entire market collapsed because the AI all read wrong signals and all the AI reacted against each other AI and everybody start to escalate the selling process. So the market really went down on that day. So AI can also go wrong. You can there's one segment in this video later that will show in 3 minutes they have already executed something like 20 million worth of trading. So there's a lot of trading involved here. Even in 3 minutes alone, they've already done about 20 million. Okay, to answer your question, which market is AI being used to trade? Any market at all, you can use trader AI to trade. You know, basically, the broker has a license with the exchange, and the exchange has given API for the broker to submit their trades. So the broker will use the API to submit their trades to the exchange. And behind the scene, the broker is actually using AI to say whether want to buy or want to sell, how much to buy, how much to sell. So it happens in any market at all. Okay, and then when it comes to algorithm, there is no fixed algorithm that is good because all the algorithms are being improved on a daily basis. So the stockbroker employ something like a few hundred programmers. Every stockbroker employ a few hundred programmers. So the programmer is fighting with another programmer in another stockbroker. So which one is better? Is the one that makes the most profit lah, the better. But which one is better? You cannot buy their system from the market because their system is being developed in-house. You know, the algorithm and all is being improved in-house by their own programmers.
Yeah, and I heard you said when there have no data, and if the data is not very big or very many, we should use the AI. Yes.
Yes, there are a few applications that you can buy outside. These applications are not used by stockbrokers. These applications are used by traders outside. You know, they are small compared to the AI system being used by the traders themselves inside. So these are what you saw just now is high frequency trading, high speed trading, which is really running on customized AI developed by programmers inside the brokers themselves. So these are really huge transactions that they execute compared to the AI that you can buy from outside, which is not as huge as that. I think it's over here. I think, okay, this one here you can see within a few minutes. This is maybe 9:30. So it's only half an hour. Already how much have transaction is being done, you know? So even if you were to buy the software from outside, you won't be executing as much as whatever the stockbrokers are doing, what you can see over here. In 2 minutes, you can see the market opened at 9:30, but 9:32, already so much is happening. Like that.
Yes, if we set a situation that there are 5 AIs to come into the market and they are all in the same line to run, and which reason or which things can make them become the winner in this market competition?
Yes, as I mentioned, the AIs in the brokers are being improved every day. Okay, so for example, you may have this broker
situation at the beginning, and which you think will be the winner in the last? Which reason decided?
There is no last because the stock market continues every day. There is no last. So the stock market continues this year, continues next year, continues next year. So the last is possibly the end of the. You can make profit in the middle. So you make profit today, you make loss tomorrow, you make profit next day, you make a loss the other day. So there is no end game. There is no closure. So the definition of the winner is who make the most money during whatever period of time. So and it keeps on changing as people improve. He may be better than the other guy, but then the other guy will improve and he become better than this guy again. So there's no clear winner in this sort of situation. But the technique that they use is the same technique. Is called recurrent neural network. So this is what we want to have a look at. Recurrent neural network. Okay. So for stock trading, we are looking at signals. Okay. There are many signals. This is just example. There are many signals. For example, one of the things that I use is called Fibonacci. Fibonacci is where I draw lines to detect turning points in the prices. Okay, sometimes if you're already fairly conversant in this game, you can draw the line in your mind. You don't have to draw the line on the screen. But you have to draw the line. So you have to use a bit of judgment where to draw the line. So for example, my first line here is the one in the middle, the 32.8 Fibonacci level held. So the one in the middle here is the original line. Then I draw a line of the same size, bottom and up. And then I draw another line, which is the length of this line multiplied by 1.618, which is the golden rule, or what you call phi. Not pi, but phi, 1.618. So the second line is longer than the first line, bottom and up as well. And then I draw the next line, bottom and up, which is higher. So Fibonacci sequence dictate the length of line that I draw. But where do I start drawing the line? And whether I know or not the pattern is correct or the pattern can be incorrect. So that one is where I bring judgment into the picture. So another one is Elliott wave. Elliott wave also uses Fibonacci principles or the golden ratio, but it's based on the market will go 5 times up, 3 times down, 3 times up, 5 times down, like that. So you can see here there's a multiple waves here, and then there's some numbers here. So this is wave number 1, and then it goes wave number 3. You see the peak. This peak number 1, peak number 3, in the middle there are some peaks, and then there's peak number 5, and then you know that once you hit the 5, there will be a market change where the market will change direction and expected to go down. But you need to put the numbers in the right place. For example, is this number 1, is this number 2, or is this number 2? So you need to use a bit of judgment there when you start to put this Elliott wave equation into play. And another type of this is where you look at the candlestick. So what you call the graph here is the candlestick graph, because it looks like a candle. So the candlestick graph says the end of the line here is the highest price during the trading, and here is the lowest price during the period. So the period may be one minute. So each of these candlestick represent 1 minute, or maybe each of these candlestick maybe represent 1 hour, or maybe it represent 1 day. So you have to change the parameters. And then if you have a short candlestick, there is normally some kind of meaning, and there is a long candlestick, that means some kind of meaning. And there is also a meaning when you have a short followed by a long followed by the short. So you are looking basically at another thing called a Marubozu pattern, which is where the candlestick is full. When the candlestick is full, that means the closing price of the stock and the opening price of the stock during that period is the same as the highest price during that period. That means the opening price and the closing price during that period marks the boundary where the prices are traded during that period. So that is called the Marubozu pattern. So, and when you look at the Marubozu pattern, it helps you to determine market changes very well. Okay, you can see here, you can see two spinning tops here. Spinning top means you have a very high line, very long line, but you have very short pillars inside the line, and then followed by this sort of already indicate to you, followed by change of direction, and then by the time it changes, you are still not sure whether this is a correct change or not. Then you have a Marubozu pattern which confirms that it is changing. So you can see the sequence here involved. You know, the spinning top and then Marubozu, and then here you have another spinning top and another Marubozu, but it's in the change of direction of going down. So this one is going up. So you want to catch this one, then you want to catch this one because you want to know during this period you should buy because it's going to sustain itself. It's change direction, it's going to sustain itself. It's not a temporary situation. And over here is change direction from buying to selling. So you also want to detect that because now you want to sell instead of buy. So what I'm trying to say here, that sequence is important in order to determine major changes in market direction. What you want to catch as a trader is you want to catch where is the market direction right now, and you want to know whether the change in the market direction is major or minor, because you need to sustain your trade for a certain period of time. So you need to have a major change and to have a momentum to carry that change forward in order for you to make some reward, or otherwise you might lose your money. So you have to look at the sequence of things that's happening in order to determine what's happening in that market. So back to what we're talking about, RNN is all about learning from sequence. So RNN, one of the things that you can use is to learn from sequence. But there is a problem when you use RNN. Remember RNN just now? It involves a sequence of, it involves a sequence. You know, it's not just looking at a particular sigmoid and then say what is your output value, but it goes into state 1, state 2, state 3, state 4 before you come up with the output value. So there is a sequence there involved, and because the sequence there involved, there is a problem. The first problem is called a decay problem. Decay problem, Fibonacci numbers, for example. What is Fibonacci number? Fibonacci number is a series of numbers that abide by the golden ratio rule. The second number is a golden ratio of the first number. The third number is the golden ratio of the second number. But how do you get the second number? The first number in the sequence is 1. Okay? So you use number 1 as the input value for the second number. So 1 plus 1 is equal to 2. And then you feed back 2 as the number to be added, but you take back number 1 here as the number to be added to number 2. So 1 plus 2 is equal to 3. So 1 plus 2 is equal to 3. That's the third number that you have in there. And then the next number is not 4 but is 5. Why 5? Because you take back the number 2 and you bring back the number 3. So 2 plus 3 is equal to 5. And then 3 plus 5 is equal to 8. 8 plus 5 is equal to 13. And you continue until you come to the point where the next number is 3 233, and the next number is 377, and then you add these two, you get 610. Now, what is the problem of decay? The problem of decay is that sometimes in the stock market, when you look at graph like this, sometimes when you look at the graph like that, when you look at graph like this, some signal, look at the Fibonacci for example, you look at the signal is very far behind. In the middle, there are some signal that is not very important, and then only you have a important signal. Then you have some signal that is not important. Then you have some signal again that tell you something. So you need to know which signal is important, which signal is not important. But the important signal can be so far behind another. Okay, in the middle there could be a lot of false signal that you don't want to listen to. So the problem is that with this is called a decay problem, a feed-forward system using a decay problem, using a Fibonacci number. You can see once you reach 610, you take back what happened early on, which is number 1. Number 1 to the next number of 610 is very small. Okay, this 610 you reach by 233 plus 377. If you add 1 to 233 and 377, so instead of 233 plus 377 is 233 plus 377 plus 1. You're going to get 611. But very small impact over here. But this guy started it. Without him, you wouldn't have the whole sequence. But after he started, his influence is decaying. His influence is decaying over time over there. Okay, so this is a problem in feed-forward, in RNN, because sometimes what is behind here is actually important. But the importance of this one is actually decaying over time. So we need to do something to make sure that we realize that behind here is something important that's happening, even though there is a decay in time. Do you understand what I'm trying to say here? This problem is a decaying problem that we need to solve when we are doing that sort of sequencing in RNN. Okay? Well, it's time for break, but we continue first. So the other one is in RNN, when you do the back propagation, just now you saw the basic back propagation, which is very simple. Now, but in RNN, the back propagation algorithm is modified. Okay? So when you calculate whether let's say for example, you predict the price to be like that, but the true price is different. So you have the error function over here that determine what error that you encounter. So that error function is in a normal artificial intelligence, it will only be passed back to your last layer. But here it is being passed back to remember, these not layers, these are states. So it's being passed back to the last state, being passed back to the second last state, to so the same error is being passed back to multiple layers for them to use. And then at the same time, once this fellow has received his error, he will also compute another error for this guy to also react. So this guy has got two errors to react. The first error is the error coming from the total error, and the second error is the error coming from the previous, the process along the chain. And this guy will also pass back his own error to another guy, and this also taking another error here. So along the chain, the error will be passing back. And this is one neuron. This is not multiple layers. So what you have is a problem of vanishing gradient. Vanishing gradient means, let's say for example, your adjustment value is 0.1. But if you pass back too long, 0.1 multiplied by 0.1 multiplied by 0.1 multiplied by 0.1, you get 1 over 100 million. This is only 4 times. Let's say for example, you have something like 1000 sequence here. So you're not talking about multiplied by 4 times, you're talking about 1000 times. The number becomes too small. Too small, the ultimate correction that you need to do become too small that it is useless for you to use anymore because it's too small. Okay, the gradient becomes too small to be useful. Or let's say for example, the number becomes too big. Let's say it's 100. 100 times 100 times 100 times 100, 4 layers already become 100 million. So the gradient becomes too big that it drowns out all other gradients. So also you have a problem here, because then you cannot use this value in order to teach your ANN, because then your ANN becomes distorted by very big values. So you have a problem of vanishing gradient and you have a problem of exploding gradient when your error function is less than is 0 point something, you get vanishing gradient. When it is more than 1, then you get an exploding gradient kind of situation. So the method is that, but then you face this problem. So the solution is to come up with either GRU or LSTM, long short-term memory. So the way is you, in each particular neuron, instead of taking the sigmoid function alone, what you do is the neuron must process the data first. See, when we saw just now the earlier model, it's very simple. The neuron receive an input and then check against the curve. So what is X, what is supposed to be Y? Very simple, just check against the curve. But in here, it's not so simple. The first thing is, you go to the first state where the data is fed into a sigmoid and then it produces a result from the sigmoid. So the Y is supposed to be this, just like the normal sigmoid. But then it goes through again the same thing, the same data goes through the same sigmoid, and then you produce a Y2. This Y2 is multiplied by, you hold this Y2 first. Just like you hold the Y1, you hold the Y2. Then you take the same data, you go through a hyperbolic tangent. And then you get the result from here, you multiply by this Y2 that you hold just now. You get the result of this, then you add to the Y1 that you got just now. And then you hold the result over here. You hold the result over here, then you take the same input again. You go through another sigmoid again. And then you get the result from over here. Then this number that you get, you go through a hyperbolic tangent to get the another Y from here. And you multiply these two, and you get the output result. So it's not as simple as just looking at a sigmoid and then what is X, what is supposed to be Y. But what is X, and you go through a process of coming out with the new Y using temporary calculation. So here you can do a homework and look at this video in how deep learning in RNN is being implemented under TensorFlow. Okay? You get the how we change just now from the normal neural network now into RNN. Suddenly you have to do all this additional stuff. So in the real world, this is happening. This is what you have to do in the real world. You will not be as simple as what you saw just now. So you use RNN for stock trading. So here is additional homework for you. This one is a very short summary of the steps involved in generating RNN network for stock trading. This one is a very detailed explanation of how you do it. Both are using TensorFlow and Keras in these two examples. This is your homework that you can do later on. And this is again another step-by-step example using TensorFlow and Keras. Why I gave you many examples? Because like I said just now, the technique is the same. The method is called LSTM, long short-term memory, not LTSM, LSTM. But different people will do it in a different way. This is called a stack LSTM, for example. He has a different modification to the method. So again, this is a homework that you can have a look. Alright, so at this juncture, maybe we can take a 10 minutes break or whatever. Do you get an idea now from what you learn in university? When you go out into the industry, what you need to do in order to transform what you learn in university to what you learn, what you're going to apply in the industry? Basically, different people will apply it in a different way. This is one guy, this is another guy, this is another guy, and before this is another guy. So everybody is doing it in a different way. Basically what they are trying to do is this. So because there is this problem, it's not as straightforward as what you learned just now. You have to do the back propagation in a different way, and you are going to encounter some problem. Because of that, you have to have some solution to do it, and this is the solution that you do it. Get what I'm trying to say? So back to the original earlier slide that I showed you. Why you can make a difference in artificial intelligence. The reason why you can make a difference in artificial intelligence is because you can decide on how to do things differently based on other people. Okay? How do I make a difference? Not all machines are designed to learn the same way. You can see just now. Okay? The theory is almost the same. But in practice, there's a lot of variation. you put this, you put that, you do it differently. So not only the data is not of the same quality, but also the method is not the same method. In order to do this, you need to learn maths. You need to know a lot of maths. You need to have, otherwise you're going to just spend a lot of time by trial and error. So if you have maths knowledge, you are able to manipulate mathematical calculations or functions in a more agile way. You would be able to do a more directed learning process than just a random trial and error process. And because machine learning involves a lot of process, so the more directed you are, the more efficient, or if the more efficient you are in terms of training your machine. If you go by a lot of trial and error, it's just like trying to hit the lottery ticket, hoping that something will strike correctly. Okay. So the second part just now in our agenda is in terms of commercial. So that RNN is an example of what happens when you are trying to do in a commercial context. You need to have strategies to handle your commercial situation. Depends back to what objective are you trying to do. Are you trying to generate, for example, artificial music, or music using artificial intelligence? That also uses RNN. Or are you trying to generate text, for example? Now we have a few engines that generate text according to whatever writer that you want to have. You want to generate, you give a list of words to him, he generate text according to Shakespeare, text according to Stephen King, text according to another writer. So those are all using RNN. So when you come to the commercial side, that's how the reality in the real world is. And you can bring your own individuality and you can bring your own quality to the equation, because you can do things better than another programmer. So it's not just the same thing that you learn everybody is using. It's not that. And I think if you try to apply whatever you have learned also in whatever place that you are working, you also find out that it's not as simple as just take what theory you have and apply the theory. But you need to be agile, and you need to be able to change, manipulate, modify, adapt, improvise in order to come up with something. Okay? So shall we take a break now? Then I will talk about how technology and business can combine in order to create competitiveness, which is important for you guys, because in the end, what you are learning, you still need to apply to the advantage of the organization that you're working in, or to the advantage of your clients, or to your own personal advantage. So we will talk about the commercial aspects of AI after this break. All right? Do you have any question now regarding the commercial side of AI, the one that I showed just now, regarding the recurrent neural network? Any questions before we do a break?
No, it's pretty clear.
Others, any questions?
Is it Malay language is mature enough for RNN? I mean, in terms of text generation.
Yes, for sure. I'm sure it can be done. But again, like for me, I will look at it from a commercial point of view. Okay, if I do text generation in Chinese, for example, I have a whole market in China that probably need my service. If I do text generation in Malay, I have a small market. Then I will look at how easy it is to do text generation in China and in Chinese compared to doing in Malay. Maybe Malay is more difficult because the nuance of the language is very subtle, whereas Chinese maybe is more gross or something like that. So maybe it's easier for me to do something like that for the Chinese market, and there's a big market there, rather than for me to do something difficult for a small market and there's no market there. So from a commercial point of view, maybe I will rather do text generation in Chinese rather than do text generation in Malay. That kind of situation. But yes, you can do it in Malay. Malay language is rich enough to do text generation. Any other questions? Okay, let's break. Now it's about 10 o'clock. Can we come back? What time shall we come back?
10 minutes after?
Okay, 10 we come back, okay?
Okay.
Okay.
Maybe we can finish it before 10:40 or something like that.
Yeah, that's possible because now the rest of the subject is not so difficult anymore because not so technical.
Okay.
Okay then. Thank you.
Okay.
Hello sir,
Yes?
saya nak tanya,
Aha.
ya. Hello,
Yes, yes. Listening.
saya nak tanya yang AI learning. So kita hanya stick pada satu indicator saja. Let's say you cakap tadi indicator for Fibonacci.
Oh, no, no, no. We don't stick to one indicator. We use multiple indicators. Because we are fighting against another person, no. This one is a competitive AI. Your AI is going to trade against another person AI. Your job is to program the AI. Your job is not to trade. Your job is to program the AI. Something else is doing the trading. So you are fighting against another trader who is using the best of everything that he has. And you also need to have a powerful weapon lah basically. So you cannot expect to be able to compete against another guy if you are too simple lah.
So in this case we can combine for another indicator lah to make a good decision like moving average or Fibonacci and also the volume also, right?
A lot of things lah. You probably use like 500 indicators or 5,000 indicators, something like that lah. A lot lah. A lot.
So okay for now for in KLSE we have too many rumors like the vaccine counter. So the AI still capable to handle this what you want.
Okay. When you are a technical player, you only look at the graph. Okay. You don't listen to rumors. You don't look at fundamental or whatever. You only look at the graph, but the graph will reflect the rumors.
Yeah, betul. Yes.
So you pick up the rumor from the graph. Dapat tak? Same thing with the fundamental. Let's say for example, katakan rubber glove industry right now. So the rubber glove industry, because there are now vaccine coming up, so people are expecting the rubber glove industry to collapse because vaccine coming up. But then again, now there's spike in the infection everywhere around the world. So there's a counter force that is changing the direction. But all these are fundamental. So how does AI handle the fundamental? AI does not listen to the news, but the fundamental will be reflected in the graph. And then the AI, when it read the graph, it will also pick up the fundamental, pick up the rumors. And then you are just basically looking at the graph aja to determine dia punya long term direction, short term direction, whatever.
So untuk kita for us to train the data, the prediction, we need the huge data from KLSE, right?
Yes, that's right.
So kita boleh minta tak dengan diorang for study purpose untuk university purpose lah, boleh?
They would have the data. I don't know whether it's publicly available, but data from other stockbroker, other exchanges around the world is available. Some old data, not the data feed. The immediate data feed tu, if you want to know the current data, you have to subscribe. There is a service. I think Bernama has a service, Bloomberg has a service. A lot of people have service lah. That one give you current data. But if you want to have old data, you can get it free on the internet.
Okay, thanks.
Yeah. Okay, so we break and we meet again 10:10. Yeah, alright. Okay. Hi guys, are you ready to resume?
Well, I am.
Okay, let's continue.
Okay.
Now, why is AI very important to nations and to businesses in the future? So AI and of course big data as well. Kalau tidak, I think you're all very well aware now that we need to have the data in order to train our AI. So if we don't have data or we don't start the practice of keeping data, the data will disappear. So it's very important for us that we should acquire data and we should also store the data. Okay, the right parameters, whether the data has enough attributes, not enough attributes, the accuracy of data, how long we store the data is important because we want to train the AI. Because AI is important, so the data becomes important. Okay? Not just for business, but also for the country, for nation, how to run the nation. For example, for healthcare, how to fight COVID, how to fight, let's say, for example, another type of pandemic comes out or something like that. So we already saw just now high frequency trading, kan? Where you have AI compete against AI. So which firm is going to be more profitable? Because when you make profit, somebody else is going to be the person who make the loss, right? Ultimately, it's a zero-sum game. Like, it's not as simple as that. It's not definitely a zero-sum game, but it's more or less like a zero-sum game because when you profit, somebody else lose. Okay, so it's all about competition, and this is really a competition of AI versus AI. Okay, for example, katakan music. So I subscribe to Spotify. I also subscribe to YouTube Premium. Okay, so I subscribe to two sources of music, but I like to use YouTube instead of Spotify because I feel that YouTube prediction model is better than Spotify prediction model. So it can predict, for example, at this time of day, normally I'm doing what and what kind of music do I need at this time of day. Spotify does not have that kind of prediction where it goes according to your daily activities, for example. Ataupun Spotify can do good prediction on old music. But if new music comes on the screen, let's say from some indie musician or some YouTuber, unknown musician, YouTube is better at predicting and presenting them to me than Spotify. Of course, one of the reasons why that is better is because YouTube has like, has zero, and has also dislike, whereas Spotify only has like, does not have dislike. Or Spotify present to you a playlist, for example, and then you can like the whole playlist. But maybe inside the playlist there are some that you like, some you don't like. Whereas YouTube you like song by song. Spotify also you can like song by song, but then sometimes you take a shortcut, you like the whole playlist. But then you also like the thing that you don't like. So it's very broad rather than very minute, fine grain. So because of that, if I have to stop one service, I will stop Spotify. I will not stop YouTube. So AI becomes important to the business. Yeah? It's all being done by AI. Now let's talk about financial business as a financial services as a particular industry. For example, okay. Now the fintech, the AI in fintech. There's a lot of AI in fintech. Okay. What are the areas where people apply AI in fintech? Number one is for you to predict and to give a credit scoring to your customer. So how much loan can you give to a particular person, or how much loan can you give to a particular company or business? So the normal way last time was to submit your account, and those are very slow and very old type of processing, where you are based also on very old data because you're based on your audited account and stuff like that. But when you use AI, you can use against current data. You can even take into account up to the last minute data, the transaction that you just purchased, you just did something. Let's say, for example, your credit scoring is very good. Suddenly today you go and buy a new car. So your loan is already used by the new car. So suddenly your credit scoring can drop immediately because you just bought a new car today on loan. But if you use the old method, they won't be able to take into account that yet because they're still looking at the old data. So credit scoring one area. Another one is assistant, personal finance. So for example, you can have AI that will help you to manage your finance better. Okay. Let's say for example, Apple, for example, they have the scheme where they help people to recover from their financial problem. So if you have a problem with Apple, so that you cannot borrow any more money from Apple, then Apple will provide you with an AI assistant that will assist you how you want to come back to becoming a good credit rating punya person. So through personal assistant. And you also have asset management. This is for wealth management. So very broad area. So a lot of factors goes into what is meant by asset management and wealth management, and also including risk management. So this is to manage your entire wealth so that you can plan by what age, how much you want to have in terms of saving, what you want to be able to afford to buy. So you can apply AI to that situation. Insurance, for example, manage risk and stuff like that. Market research, definitely. Sentiment analysis, I mentioned just now. Consumer sentiment, their confidence in the country's economy, all can be managed by AI. AI, for example, can read the news, or can read the social network, and then try to determine what kind of sentiment the market has about things. Business, finance, and expense reporting. Okay, this is where you use AI to analyze how to improve your financial management in your company. Regulatory, compliance, fraud detection is where you try to use AI, for example, to detect fraud, or use AI to, for example, to detect anti-money laundering, because the transactions are too many already. We cannot use the old way of manually auditing transaction, because there's too many transactions. If we want to audit 1 year transaction, but it will take us 5 years to audit 1 year transaction, it's going to be a game that we'll never be able to chase up. So we use AI in order to detect possible fraud. For example, credit card fraud. Too many credit card transactions going on. You cannot do it manually. You use AI to detect some transactions could be fraudulent. So then it will alert the people who are doing this sort of work. And also, of course, predictive lah. Let's say, for example, you want to know if I were to produce this insurance product, is there a market for it? How big is the market? How do I reach out to that market? Those are all prediction. So then you can use AI to help to predict those kind of trends, or attractiveness of a product, or something like that, or even predict the general economic environment, expansion of market and stuff. So in financial industries, okay, when you talk about fintech, there are about quite a few areas of fintech lah. So I would divide the area into, the one area is payment, like PayPal, like IP88. Those people are involved in the payment, remittance, foreign currency solutions. Then you have e-wallets like Touch and Go, Grab Wallet. So that's another area of fintech. Third one is lending. Lending is like funding societies, money safe. They use those are fintech companies involved in providing loans. And then you might have Investec. For example, Hello Gold, for example, you can invest in gold. It's also another fintech company. One area is wealth management. This is where you manage your overall wealth, that I mentioned just now. And then you can also have insurance, InsurTech, which is for insurance, micro insurance. You can have your RegTech, regulatory, just now I mentioned. And then you also have, of course, the big market of digital currencies, tokens, smart, all things to do with blockchain and smart contract and stuff like that. So those are the solutions in the market, and these solutions are all financial solutions, but they are also technology solutions. So they've got fintech solutions, and then you can apply AI in all these solutions. So you can see how big is the market for AI, even in financial services alone. I'm not talking about manufacturing service industry, we're not talking about tourism industry. So there's a lot of places where you can use AI. Okay. Now, then you're talking about the market of people who's going to use these kind of things. Okay, let's talk about katakan SME, for example. Those people who consume these fintech industries are normally the people who are underbanked. Underbanked could be, for example, good businessmen, but because of secrecy problem or something like that, they cannot apply for loans under normal bank. So these people are called underbanked. And then you have micro SMEs. SME like Makcik Kia, for example, very too small. So very hard for them to deal with banks, a queue, and then all the process and everything. But they go through fintech, they go through the app, apa semua, they can get, you know, whatever they want in a matter of a few minutes or a few seconds. Then you have the millennial market, the young people with their own trends, fashion ke, music ke, entertainment or whatever. So that's another market. And then you have your SME market itself, the small or medium scale industry, from the small, katakan this pakcik, he produced pau in his backyard in Puchong, for example. That's a small guy. Or a bigger guy could be a kerepek factory. Or a bigger guy could be somebody who produce a sambal kering, for example. And then a bigger guy maybe somebody who really produce something, but still small scale industry. Say for example a factory that produce some of the component parts that is used by another big factory. And then you have cooperatives. Cooperatives also another market. And SOHOs. And a lot of cooperatives are still not using fintech. We have 14,000 cooperatives in Malaysia. The biggest 100 cooperatives headed of course by Bank Rakyat, they are financial industry player. Most of the big cooperatives in Malaysia are involved in financial services because they provide loan for their members. So a lot of them are still not moving into fintech. Definitely very few are using AI. So if the trend starts over there, then you know you can also start using AI in those places. And then you have SOHO. SOHO are people who freelancer, for example. Okay, you know these days it's very hard to find jobs and people do freelance job and stuff like that. So even SOHO can be a market where that consume all these fintech services. And so SOHO tend to be underbanked because you know banks normally don't provide loans to people who don't have enough documentation like SOHO. So the fintech industry can be the one who serve these people. And of course we have the other small pockets who are immigrants market, for example, expatriate market, student market, retirees market, women market, traders, small traders like people who know drop shipping, for example, traders, startup companies, manufacturers, farmers, freelancers. So these are the whole area that we are looking at in terms of providing financial services through fintech, and AI can play a role in all this, in addressing the needs of these industries. So when you apply AI to financial services, other industries are similar. Okay, you need to have what? You need to have, this is what you need to learn. This is what you need to train yourself in order to be marketable, in order for you to be relevant in the future. You need to have domain skill set. Even if you are studying IT, but you still need to have domain skill set. Domain skill set means subject area. You need to know a bit of finance. You need to know a bit of accounting. You need to know to read how a balance sheet, how to read profit and loss, how to read cash flow statement. You need to know a bit of financial ratio, a bit of accounting sense, what is the meaning of accrual financing against cash flow financing, a bit of cost accounting, a bit of variable costing, for example. You need to know a bit of accounting. And then you also need to have a bit of a hold on the law, contract law, tort law, damages, what is you know, the new laws about what can be done, what cannot be done, which keep on changing all the time. So you need to have a bit of understanding of the legal process as well. And then you need to have management. Of course, you need to know some management skills. Definitely you need to management skill, because this is a general skill that you need to apply in every situation, including communication skills, management skills, project management skills, people management skills. So those all fall under management. How to coordinate work, how to delegate work. Some people, you know, become very, you know, just don't know how to delegate work to people. Some people delegate too much but don't know how to control. So too much delegation is too bad also. Then the manager end up not doing anything, or that means the manager don't even want to know what is happening, or the manager can also be doing too little delegation. Risk management, some marketing skill, and definitely customer service, because customer satisfaction is at the root of everything. So those are domain skill set that you need to learn, even though you're studying IT or something like that, and it has a bearing on your ability to produce AI solution. Because when you try to design your AI solution, it has to be targeted to specific industry problems, and in order to understand and appreciate the industry problem, in order to understand and appreciate also the solution to the industry problem, you need to have these domain skill sets. Okay, and you also need to have AI skill sets. You need to learn AI programming, Python and all that. You need to not only programming, but also you need to know architecture. So you need to be an architect, not just be a programmer, but also be an architect. And you need to have, of course, to know data engineering, because you need the work before you start to consume the data, and you have to prepare the data first. That involves a lot of issues that you need to appreciate, so that the data engineering skill come into play. You need to know mathematics, because you need to be able to manipulate the formulas. Whatever you learn in school and whatever you apply in industry will be different. But then in order for you to apply the different things, not in a random way, but in a directed way, you need to have a strong grasp of mathematics. Okay, so that you can manipulate mathematics in a very agile way. And you need to have statistics, of course, because you need to see correlations, relevance, whether your sampling is correct or not, whether you can rely or not on your sampling. This is where you can, for example, be relying on the wrong sample, and then you in the lab your model is producing a lot of fantastic great stuff, but when you roll out into the marketplace, it fails because you know your sampling is wrong, for example. And then of course your AI project management is not the same as a normal software project management, because it involves a lot of experimentation and a lot of uncertainties. So how do you manage? Not only managing in terms of managing timeline, in terms of managing people, managing resources, managing computer resources, because it's a very resource intensive exercise, AI, in managing the people there who's doing the experimentation. How much can you force them to work? How much can you not force them to work? And how can you direct their knowledge in the right direction? So all those fall under the ambit of AI project management. So what's next? What comes next is this. Okay, AI is very important to survive as a nation. Okay, so a lot of countries already recognize this. Singapore has an national AI policy. Singapore has a national artificial intelligence strategy. So those are the details. China is very big in AI very early on. They have two policies, two master plan. One is the AIDP, AI Development Policy of China. Number two is the Made in China 2025. You combine these two policies, okay? So what they want to do is geopolitically means how much they control the world. They want to maintain themselves to be competitive with major superpower. They are not trying to fight against Malaysia or not to fight against Indonesia. They are trying to fight against US, for example, in terms of competitiveness. So, or in terms of money management. So the AI industry alone is something that China can sell solutions to the world. And at the moment it's worth 150 billion yuan, and they want to increase it to 1 trillion yuan at one point of time. They want to develop the dominance of the market. And then from a legal and ethical point of view, they want to develop also policies on how to manage AI so that AI is applied in an ethical way. Because AI can also be applied in an unethical way. For example, China has stopped Alipay from Ant Financial from going for listing, because according to them, Ant Financial is just adding the debt burden of their citizens. So the people of China become heavily indebted because of the easy credit that Alipay is giving to these people. So they don't want their people to become victim, not to be a victim. They don't want their people to become too indebted to fintech players. So they stop that listing of Alipay, for example. So there are ethical issues and other issues involved in rolling out AI. So China is also developing those policies. They are thinking about it, and they are coding the laws, ethical standards for AI to adopt. For example, Google also has ethical standards for AI, and you can look it up. Indonesia also has a national AI policy. Thailand has a national AI policy, and many other nations has AI policy, and these are the timeline. Canada has, Singapore has, definitely Israel has, Finland, Taiwan also has. I don't see Malaysia on the map, but there is one company in Malaysia that roll out a national AI blueprint, but this is published by a company, by Bijit Sdn Bhd, not by the government. It's still a good blueprint. So you can look at this blueprint. For example, they have identified certain sectors. Telecommunication sector, this is where you can apply AI. to build cellular tower, to supervise, to reduce the customer churn, so that customer don't move to another telco. Network capacity, manage capacity, manage demand, like I said just now, where you can auction your network. Operational intelligence, that is to manage your intelligence. So then you have your telecommunication industry, you have your media industry, entertainment industry, you have your aviation industry, banking industry, healthcare industry, retail industry, and various other industries. And these are the solutions, the AI solution that these industries can have. You can look at it. There's so many solutions that you can roll out. And if people have these solutions, their product may be better to customers compared to people who don't have these solutions. So I want to impress here to you that AI is very important, that whatever you're learning is very important, it's going to gain a lot more importance, and try to influence Malaysia to have its own AI policy, okay? Because maybe we don't realize that, how important, maybe we don't realize what other people are realizing like that, because we need to have this national AI policy really thought out, okay? Not only in terms of impact to the work, because we may be losing a lot of jobs due to AI. At the same time, there is also opportunity in the AI sector, in the big data sector, in the security, data security, sector. So we need to do a pivot though, where our workers may have to be able to, we need to find a solution. Basically, people are losing jobs. At the same time, there's a demand there for certain kind of people. So this is where, moving forward, what next is where we bring it up to become a national agenda, where AI is going to have that sort of importance to the nation, and we really use AI for our various purpose, including to improve the competitiveness of our businesses. Okay, so this is the skills that you need to study again. These are, for example, one area, financial services, but also in other areas also you can think of the same thing. So that is how you apply AI within the commercial context. Okay, just now early on you learn how AI is applied technically, what is AI in a technical sense, and then moving from the university to the industry, specifically what kind of change that you need in terms of to adapt the AI to the industry, and then moving forward, like what is the importance of AI to businesses and to industries. So, back to our objective. What can you expect from this lecture? I want you to have, by the end of the lecture, maybe a roadmap of your learning journey. So what you have seen just now was AI in the university. You have to cover these topics: artificial neural network, and then how you implement it. So you have a rough idea of what you need to learn in order to master neural network, especially in terms of deep learning. And then moving forward, you still have to learn not only in your university but outside your university. When you move to the industry, you have to apply what you learn, how you apply what you learn. Okay, so I hope by now you already have a roadmap of your learning journey ahead. And then you will also appreciate how AI will be relevant to business competitiveness. Right? I think a few examples have been given just now. Spotify, YouTube, for example, especially in the stockbroking industry. How a stockbroker can become more profitable than another stockbroker because they fight using AI. So I hope by now you appreciate that AI is very important moving forward in our current world context, commerce context ataupun economic context. That AI is going to be very important to keep us ahead of other people. And you also appreciate how you can make a difference in how you design your AI compared to other people, because even though the method appears to be the same, but actually when you implement it, it's not the same. It depends on your creativity, it depends on your understanding, your wisdom in how you want to apply the technology to the specific business case or circumstances. And finally, I hope by now you also understand the fundamental skill areas that you need to master. By looking at the example I given just now, you can see where is the mathematics that you need to study, where is the calculus that you need to study, where is the domain area that you need to study. For example, the financial sectors, in particular the stockbroking industry, stock prices just now. So, in order for you to roll out a real world solution, because we have a lot of job opening for AI programmers, but it's mostly filled by non-Malaysians. Even in Malaysia itself, we have a lot of job opening that is not filled by Malaysians because when employers evaluate our programmers, they have still not yet reached the ability to produce a real world solution compared to programmers from India who went to study to United States, for example, or the sort of people lah. Jadi by this, I hope you understand now. These are the areas that you need to beef up in order for you to become suitable for the industry, and then by that you improve your chances of being employed with a higher pay or being paid in foreign currency or something like that from the industry perspective. So I hope I've delivered to you these expectations. I would like to ask, okay, so this is me. This is my profile on LinkedIn. Here is my address on my profile. I'm going to publish a copy of this lecture again, as well as the slides. You can download the slides. I will provide the link all on my profile on LinkedIn. So please subscribe to me and please become my connection so that you can download this material and we can have a discussion. We can carry on further discussion on LinkedIn. There might be other questions from other people not involved in this lecture today on LinkedIn asking about the same topic. I think some of you are already quite well versed. I think I would say all of you have some conversation with the subject matter, and I don't have to answer all questions. You guys can answer the questions, and by answering the question, you are also showcasing yourself. You are showing to prospective employers that you also understand the subject, and you can also answer questions or you can provide explanations. So I won't hijack the conversation until there's a stalemate or there's no answer, then only I will come in. So I leave the forum open to you guys over there on my LinkedIn. I'll publish it on my profile, the lecture note as well as the recording of this session. I would like to go back to the young lady just now. Her name is Sari or something like that, is it? The one who did not study IT? I'd like to ask you guys who are not studying IT on what do you understand about AI now after completion of this the lecture?
From what I learned, I know that machine learning can help the industry, especially in determining and analysis and doing some of the like prediction model and some sort lah.
So I hope that that you have got some benefit lah from this lecture, even though you not study IT. At least an appreciation of the AI and how the process, of developing AI application goes through and how it can fail and how it can succeed lah basically. Okay, any last questions? I see here there's a topic about whether or not reinforcement learning is part of deep learning and all that. I don't want to drag on this question because why? It's not important lah basically. You can call it whatever lah. The important thing is be able to produce a solution. So again, this is a mindset that we need to adopt in order to be able to be competitive in the industry. Don't get involved in too much of semantic arguments lah, because this doesn't add value to anything at all. I also can argue why it's part of deep learning, but the main thing is from an industry mindset. Be involved in productive argument. It doesn't lead to anywhere, whatever you want to call it pun. In the end, what is important is whether you are able to produce good solution or bad solution. That's all. Okay, that's the way I think lah. As an industrialist, that's the way I think. So I just want to impart that same kind of thinking to you guys. Any other last questions?
No, I think you gave us very clearly.
Sorry?
I think you have told us very clearly.
Oh, thank you very much. Donyang, are you from China?
Yeah, I'm from China.
Oh, welcome to Malaysia. Do you have a lot of Chinese students in UPM?
students, but not many. In this
Ah,
class, I guess maybe 3 or 4 students from China.
okay, good, good. Welcome to Malaysia. How long have you been in Malaysia?
I have never been to Malaysia. I'm the master of this first semester.
Okay, good. I know there are a few Chinese students studying in private colleges in Malaysia, quite a number of them. For example, UCSI in Cheras, for example, there's quite a few Chinese students. It's very good lah. Welcome to Malaysia, and I think your country is doing a lot of good progress in AI. We really need to catch up with your sort of progress, basically. I hope you will
Yes,
be
I
here
have
to share the way you think. To share the way you think, don't be shy. I know a lot of Chinese students here. I know a lot of Chinese workers here in Malaysia as well. I've been involved in project where I have a lot of Chinese workers under me. So I know that you guys tend to be shy, and tend to be not outspoken. But don't be shy here. Share how you think. Share how you think with the Malaysians and try to absorb. I mean, that's why the Chinese government send you here. Try to absorb also how we think, because the inter-geographical relationship between China and Southeast Asia is going to be very important. And you are probably one of the good managers for them to appoint later on to manage some of the China initiative in the Southeast Asia, especially in terms of IT and AI.
Okay, I think so.
So thank you very much for your compliment just now. You were saying that everything is very clear. So anything else that others would like to chip in? Anything else from the rest?
I think everyone is very thankful for the lecture.
Yeah, most welcome. You're all most welcome. Thank you for having me for the lecture. So if everything is okay, then I pass it back to Dr. Izam. I pass it back to Dr. Izam.
Okay. Thank you very much, Mr. Khalizan, for the great session today. We are very grateful for your time and the effort you take to share your thoughts and experience with us. I think we all have been exposed to the many real world applications that you have talked about in industry, right? You have presented us with wealth of information, tips, and most importantly, the fundamental understanding of how the neural network works, right? And the many extensions of neural networks, like recurrent neural networks. I think we all now have deeper understanding, right, of that concept, and also the importance of pursuing ML and machine learning, right, or AI in general for our future benefits, right?
Yes, yes.
Perhaps students here, our students for today will be able to contribute their own parts with their own research in ML in the course of their study here in UPM. Again, Mr. Khalizan, I thank you very, very much. I think this wraps up our session for today. It's been a very long session, but I think it's very beneficial to us. Thank you very much all. Good night, everyone. My students, I will see you next session on Wednesday. Thank you very much, Mr. Khalizan.
Yes, thank you all.
You're most welcome. You're most welcome. Don't mention it. It's okay. Just connect to me in LinkedIn and we can continue to have discussions over there, right?
Yes. Don't forget to click Mr. Khalizan's LinkedIn session. I will also share Mr. Khalizan's slides in Putra Blast. Maybe we need to take pictures. Some of us who is available before we go.
Sure.
Maybe we can take pictures. How are we going to do that? Okay. Can we all turn on our camera?
Yes.
Yes. Okay. Lepas tu print screen kan? Okay. Hang on. Let me maximize this. Okay. Okay, smile. Everyone's ready? Latesh? Sina? Hashima? Hang on. Let's give some time to the rest to switch on the camera. All right, Sina. Okay, everyone's ready? Okay,
Yes,
smile.
ready.
1, 2, 3, hang on. One more time. Okay. Okay, hang on. Okay. Okay, good night everyone.
Good night, everyone.
Assalamualaikum.
Waalaikumsalam warahmatullahi. Thank you very much again.